Welcome to Math Tape 062. This is the first of two tapes on simplifying variable expressions. As you watch the tape, be sure to take very careful notes. Mark on the notes that you take anything you don't understand or any exercises you miss from those that I give you to work. Then ask a lab instructor or a tutor for help when you go to the lab. One of the things you'll find on this tape is a list of number system rules that will stay with you throughout your study of mathematics. These rules apply to rational numbers and to real numbers. They enable us to work out expressions, problems, equations, exercises of all sorts, and they're a very, very important list of rules that you need to be familiar with. Be sure to write these rules down by name and familiarize yourself with these rules by their names so that when I refer to one of the rules, you'll know what I'm talking about in future tapes. Our objective on this tape is to simplify variable expressions. We're going to simplify expressions on this tape by adding terms or multiplying factors. We need some definitions, so let's begin by defining like terms. Like terms are terms that have exactly the same variable part. Like terms are terms that have exactly the same variable part. For example, 3x squared and the opposite of x squared over 2 are like terms. Notice that the variable part in 3x squared is x squared. The variable part in the opposite of x squared over 2 is x squared. Therefore, these are like terms. (4a) and 5a squared are not like terms. The variable part in 4a is a. The variable part in 5a squared is a squared. These are different variable parts. Therefore, negative 4a and positive 5a squared are not like terms. 6/7 and negative 8 are like terms. 6/7 is a constant. It has no variable part. Negative 8 is a constant. It has no variable part. They are like terms because their variable parts are both absent. They're both constants. Constant terms are always like terms. Let's now simplify expressions by following a process called combining like terms. To combine like terms, add their numerical coefficients and keep the variable part unchanged. To combine like terms, add their numerical coefficients and keep the variable part unchanged. To combine like terms, add their numerical coefficients and keep the variable part unchanged. Let's take an imaginary trip to a garden shop and consider buying rose bushes and bags of tulip bulbs. Let's say that we pick up 8 rose bushes and 5 bags of tulip bulbs, but then realize that without a sunny location we can't plant very many rose bushes in the yard, so we'll put back 3 of the rose bushes and pick up 2 more bags of tulip bulbs. 8 rose bushes plus 5 tulip bags, subtract 3 rose bushes, add 2 tulip bulbs. So how many of each have we got? Well, we're going to put together the rose bushes to find out how many rose bushes there are going to be. We'll put together the tulip bulb packages to find out how many tulip bulb packages there will be. And so, let's group them by putting 8r, subtract 3r together. Let's put 5t plus 2t together. And then 8r subtract 3r can be found by taking 8 subtract 3 before the r. 5t plus 2t can be found by adding 5 plus 2 before the t. 8 subtract 3 is 5. 5 add 2 is 7, and so we get 5r plus 7t. Well, if we had 8 rose bushes, we put back 3 of them, we ended up with 5 of them. We collected 5 bags of tulip bulbs and then 2 more bags of tulip bulbs. That gave us 7 bags of tulip bulbs. And so the answer, 5r plus 7t, makes sense. But look at the steps in between. When we rearrange things to put the r terms together and to put the t terms together, that required us to switch things around and group them together using parentheses. When we took 8r subtract 3r and wrote this as 8 subtract 3 all times r, likewise 5t plus 2t we wrote as 5 plus 2 times t. That enabled us to do simple operations, 8 subtract 3 to get 5, 5 add 2 to get 7, and come up with our answer by using something we already knew well. So this rearranging, regrouping, and then rewriting got the expression down to a very simple pair of operations, 8 subtract 3 and 5 add 2. What justifies the rewriting that we did? Why were we able to do as we were? Now, we're interested in 2 things here. One is to do exactly what's described here, to combine like terms. Which ones are like terms? 8r and 3r are like terms. 5t and 2t are like terms because their variable parts are the same. To combine like terms, we add their numerical coefficients. If we add 8r and negative 3r, we would need to think of this as add negative 3r. Adding 8r and negative 3r, we got 5r. Adding 5t and 2t, as we did here, we add their numerical coefficients, 5 and 2, keep the variable part unchanged, to get 7t. So one thing we're interested in doing is combining the like terms to get our result. The other thing we're interested in doing is justifying the steps that we followed to get that. Rarely do we write all of these steps, but we're looking at the number system rules that allow us to rearrange the problem and get it down to its simplest elements.